Hi everyone, this is coming to you from Education for All. We are still on calculus. While we are talking about calculus, this is mathematics lesson. You've seen this book around, Mathematics from Hate to Tolerate, Beginner's Journey through Algebra. I encourage you to get a copy of your own from Amazon. It's quite, it's not expensive. It's not an expensive book. Get your own copy to unlock your potentials in mathematics. This will help you. Thank you. So, where we stopped earlier on, we're talking about our instantaneous speed, for example, here. And we gave a scenario of a car. You're driving your car, your speedometer is displaying how fast you are going, because what it's telling you is how fast you are going with respect to the distance you're covering. So what you see there, the speedometer is giving you on the screen of your speedometer is giving you that speed you see, 20 miles per hour, 30 miles per hour. Those numbers are just estimates, they are not exact, because where you reach and it says 30 miles per hour, your distance there doesn't exist. The distance is zero, and even the time is zero. It doesn't exist there. That instant, I'm not talking about average. Don't confuse with average speed and instantaneous speed. Newton was interested in the instantaneous speed. What happens to the force of gravity when the Earth planet is here? What happens to it when it is here? What happens when it is here? What about here? Here. So the instances he was looking at, not the average after it has gone one whole orbit. Then you calculate that. No. It's not like that. Because as I told you earlier on, this idea now we are trying to establish here, it was what unlocks space exploration, space travel. This little idea is what makes calculus, it's calculus. So when you want to calculate your instantaneous speed, you get the distance traveled is zero because you are moving your car, you stop here. You want the speed at this point. The speed you are coming with is from another point up to here, but you want the speed at this exact point. The speed at this exact point here is zero. The time at this instant, this exact point is also zero. So you're getting 0 divided by 0, which is at that time, 16th century. Mathematicians were not able to give that answer. Divide something by 0, 0 over 0. Right? Today, we can say it's error from your calculator, or we say as I at infinity. Okay? So then, how did he overcome this problem? That is ingenuity now. He said, okay, I'm not going to look at the instant speed. I'm going to take it from somewhere here. I cut it little by little, 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 up to the time I reach here. Right? Newton measured speed over small interval of time, making the intervals, he measured speed over a small interval of time, making the interval smaller and smaller. You can see this line here, from here to here, this line is longer, it's longer, it keeps on getting shorter, 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 until it reaches here. If you draw a line here, this is what we call a chord. Yeah? But when it's cutting through the circle, all these lines here is what we call a secant. I drew a circle because these words, they come from here. This is a secant. Secant. Yeah? So he's looking at these intervals keep decreasing, decreasing, decreasing until they reach this point. sorry, yeah, until they go closer to this point. Because when they reach, you need 2 points, as I told you earlier on. When it is here, this is a tangent now. But you need 2 points to be able to get a gradient. You need 2 points. That's why we cannot get a gradient here. The graph here, the earlier, the straight line graph, you can get a gradient because you have a straight line and it can measure its steepness. What is a gradient? A gradient is the steepness. Steepness, steep, how steep something is, right? So now you could say, I'm not trying to get the value at this point because it will be 0. It will be 0 over 0, no answer. Instantaneous velocity, no answer. When it reaches here, it's 0 over 0, no answer. But I will measure when it is close to this point. So what is this idea? In the field of mathematics, this idea is what we call limits. Limits. This is what we call limits. And the whole of calculus, the entire branch of calculus, sits upon this idea of limits. Without limits, calculus will not exist. This idea will just explain. That's why it's good to understand this basic principle of calculus before you jump into calculus. Because when you jump into calculus, you meet a lot of problems and a lot of formulas. You can use them, get your answer correct, but you will not be able to understand calculus. You will not be able to understand calculus. So this limit idea is what enabled us to solve, what enabled Newton to encounter to solve this problem he encountered by how much does gravity change over distance. This idea of limits. So he's not trying to know this exact value, but he's trying to try to understand what happens when the instantaneous speed, for instance, is close to this particular point, where here we already said it will be 0 all over 0. So he's not trying to get the average, the instantaneous speed at this point. It will not exist here. But when it is close to that point, what happens? So he introduced the idea of a limit. Of a limit. So then, what is a limit? Have this graph. This is your, that's why sometimes I do my drawing before time so that we don't waste time. Let me just say this is f of x and this is x. Correct? F of x, y is equals to f of x, and this is x. Then you have this kind of line. Let me see here, y is equals to f of x. You have a point here. You have another point here. Imagine this is a straight line, okay? I'm trying to draw a straight line. So this graph is y equals f of x. We have already done functions. So I hope you understand when you see this kind of thing. So I'll stop this video here and I'll just introduce limits on its own because small mathematics involved there. Thank you for watching. Bye-bye.